Okay, so my wife went and did a thing where she went onto my eBay account and she ordered everything that was in my eBay cart, which conveniently at the time had all the right parts to finish up the car, at least to get it running, with the exception of an overflow tank. But I think I probably have the parts here to do the overflow. So while I'm still waiting for four of the pieces for the intake boots to show up, I did get one piece, and it is a major piece, and I didn't have any, and I was hoping to buy it, but just didn't get around to it, and other reasons. So she went ahead and ordered the stuff, and this showed up already. So what she got me was a 16-inch 3000 CFM electric fan for the radiator, and I tested on it with a 9-volt in the house, and it spun up, but not a lot. So I'm going to do my best to keep my fingers out of where they're going to get minced, and try to do this with one hand. No, this is probably going to work out even better. That moves a lot of air. So I'm going to say something about this fan, in that this is, the package says 18 performance, and I think yep, 18 performance also makes the diagnostic link connectors I use on the harnesses. So I've got 0 problems with these. So I expect to have 0 problem with the fan. The fan was, I believe, $38 US, which converts to whatever. I don't have my phone on me. I can't even do the math for you because I am not a mental math person. But 35% is where we were at when it got bought. 35, like Canadian dollars, 35% more than the US dollar. So I think that puts it somewhere in around that 40, even let's say $50. And that is a cheap electric fan for mounting. So I'm going to go and get the digital meter and see how many amps this pulls on a flat surface, and see if it blows. If I have my amp clamp here, which I have the feeling I don't. So we'll see. Alright, I got my digital meter here. Oh, saw, get out of the way. Oh, man. And I don't think this is going to do much good, because I think this meter has got a blowing. Oh, it's got a blowing something in it. Let's go. Sure. Let's do it like this. I'm probably not going to be able to see. Oh, yes, it is going to work. So, let's see how many amps this thing draws. Ooh, it's enough that I feel it with my fingers. So we're going to open it up a little bit so it can move some air, so that should be the maximum amount of voltage that it's going to be pulling. It doesn't get so hot that I burn my fingers, but it feels warm. So let's see where it's at. So that showed half an amp, 12 volt. Let's change this over. Sorry, cancel that. That was half a volt AC amps. So that doesn't work. Let's try it. Pretty sure. Let's just do this again. Yes. Alright. So, it is now on DC, which we need. And see how many amps it pulls now. That's better. So that pulled 18 amps right off the bat. So you're going to say right out of the gate is 20 amps. So it goes down to 8 or 9 amps, which is fine, but startup is where you're most concerned because that's where it's going to blow your fuse. So it's going to need at least a 30 amp fuse on here. And while this wiring is not adequate for a 30 amp circuit, for continual 9 amps it is, because this is, I'm going to say even 16 gauge wire on this thing. So it's a little bit on the shy side, but see if I can hit that 18 amps again. See, and it's not enough to blow the 10 amp fuse in this multimeter. So let's see what it is on full flat. This is where a digital multimeter does not shine, because it's too slow of refresh on the display. So if you had an analog gauge, it would show bang, it would spike, and then it would come down. And I do have an amp gauge here from a battery charger that I have used in the past. I'll have to go find it, see if I can find it. But let's see, right on the flat deck, see what it'll do. Same thing. Okay. Let's use the water pump plug that I machined, and we'll block it up. Probably won't be enough. We need to block it up higher. What else do we have? Here! How about a yoke from an NP 260 something. Hopefully it's not going to fly off on me, but cross that bridge. If I wreck my fan, it's, you know, whose fault it is. Yeah. I don't like that. Try that. It's got too much torque. So that time it went down to about 5-6 amps. Now that, you gotta remember, is free draw. It is pulling all the free air it can. It's not sucking through anything. So on full load you're looking at about 10 amps. So you want to have at least a 35 to 50% error ratio on your fuses. So even 50%, that's a 15 amp fuse continuous. But it's that 20 amp startup that's going to blow that fuse right now. So really, a 30 amp fuse is what it needs. And it does say that in the instructions, but I did want to verify that. So in the instructions, it has a basic fan diagram. And you can see that it calls for a 30 or 40 amp bus fuse on a 30 amp circuit breaker supply. So pretty much confirms it, but I like doing a real world test and seeing what it'll do. So that's accurate then. So we'll put that back in the box until we fab up a fan shroud and get into there, because now we have that. Now we can make our fan mount and solidify where the radiator goes and whatnot. Also, it's gonna go right down in there, but I didn't mount the radiator because there is a cross member that I want to keep in there for stiffening on the front, seeing as how I took the cross member, I cut the cross member off on the bottom that I have to tube yet or put it back in place, but I can't do that because I have the oil pan ready to go on. So once that's done, then we'll see when we get to that point, but at least we can finish the cooling and get that all done. So once the boots come, that's the second part of the shipment. I need to make a flange tool to make those fancy ribs on there, and then we can put together the whole air intake system, and then that'll be done. You know, there's only about 365 more items left to do on the engine itself, so we'll keep plugging away when we get time.